2 sections we're going to finish up this week that will wrap up everything we need for our upcoming test. So today we're going to do 4-1. Tomorrow we're going to do a fun activity, and I'll keep it a surprise for now. And then Friday we're going to do 4-2, and then that'll wrap up every section we need. All right, so we're going to start today. You with your groups are going to fill out the front page of this worksheet. And then we're going to talk about answers, we'll throw a couple formulas in there, and then we'll do the back side together. So the first thing I need everyone to do, and then you can get started on the front, is I need you to put a tally mark, let's say above here, with how many siblings you have. Okay? So tally mark above. Go ahead, on board. How many siblings you have. You may include step, half, all the things on the top there. We're going to put probabilities underneath. Yep. Okay. A few things up on the board, so you might want to do that. Okay. So, correct answers for your data. Okay, so this is a probability distribution table that we're creating, which is what this section is over. So in a little bit, we'll do some calculations with this type of table, but this is how you create one. You find the probability of each outcome, and then you put them in a table, and you can do different things with them, like make a histogram. Your bars should be touching because it's a histogram. We are graphing my x-axis number of siblings. My y-axis is probabilities, or my other set of data. Yep.
Should the 1 be greater than 2?
Greater than, where am I looking? Hold on.
On the histogram. Like
the bar be
it's
between. Oh, did I flip my bars? I made it 9 and then 8. Yeah. Or something like that. I was thinking it was bigger, smaller. Like that? Better? Yeah, okay. Thank you. So we can make lots of different graphs with them. The histogram is usually the more common one that you're going to see. This is quantitative data because it's something that can be counted, and that's going to be important when we see the definition of a probability distribution table in a minute here. Okay. At the bottom of your paper, your calculations ended up being pretty easy, especially because nobody in here had 3 siblings, so you see a lot of kind of similar answers. So are all probabilities between 0 and 1? Yes, as any probability should ever be. When you add all of these up, you get approximately 1. When I added them up, I got like 1.001 because of rounding, but it should give you approximately 1 when you add up all the probabilities in one of these tables. In words, probability x equals 3 is the probability of a randomly selected student in the room that has exactly 3 siblings, and the probability in here is 0. If they have 3 or more siblings, that's what the greater than or equal to would be. That's 0.053, and then just greater than 3 is also 0.053 because 3 is 0. Number 7 at the bottom. If y is minutes that somebody runs a mile, is 5.7167 a possible value? Yes, if we are including partial minutes, which we possibly could. Usually when somebody runs a mile, we include seconds or whatever as well. Okay. Any questions on the front? Okay. The next couple of slides are not on your paper. It's not really anything you need to write down. We just kind of need to like talk through a couple things. So first of all, x represents a random variable. We've seen that a lot in our problems before. But now we can take a random variable and split it into 2 groups, either a discrete random variable or a continuous random variable. A discrete random variable is what we need for these tables because it is countable, okay? If you can count it, we can create, columns in our table and we can calculate the probability of each. If something is continuous, it is not countable. I can't create those little columns in my table and find the probability of distinct groups. So we need to make sure for these that it's at least discrete. So a couple quick examples at the bottom. Let X represent the number of Fortune 500 companies that lost money in the previous year. Number of Fortune 500 companies, is that something that's countable? Yeah, it's a big number, but it's countable. Okay, so that would be an example of discrete. Let X represent the volume of gas in a 21-gallon tank. Is that something that is countable? When you fill up your gas tank, does it go from 0 to 1 to 2 to 3? Does it jump over values, or is it continuously filled? It's continuously filled, right? I can't count the gallons unless it is exact gallons or half gallons or some other unit. So in general, volume is something that's measured, not counted. So that's what we would say is continuous. So that's something that we wouldn't be able to make a table out of unless like we rounded to the nearest gallon. Okay. So at the top, real quick, maybe discuss with your groups, decide those 3 situations if they represent discrete or continuous random variables. All right, speed of a rocket, discrete or continuous? Continuous. It's measured, not counted. Number of calves? Born on a farm? Discrete. I can count it. Number of days? Discrete. I can count it. Okay. If you have a probability distribution table, a discrete probability distribution table, and you want to check that it is 1, which will be some of your Math Excel problems, you want to look for 2 conditions. Number 1, we know probabilities have to be between 0 and 1. So if you have any probabilities, any values outside of that, bigger than 1, smaller than 0, it is not a probability distribution table. Also, the sum of all the probabilities should equal 1 or approximately 1. Okay, so with your groups, here are 4 potentially probability distribution tables. Check those 2 conditions on each of these and determine if it is or is not a probability distribution. Okay, so we're looking for, again, that all the probabilities add to 1 and all the probabilities are between 0 and 1. So some of these might be quick ones to throw out. All right, again, these should be quick. What do we think about the one on the top left? Yes or no? No, why not? 1.07 is the sum. Okay. So, no. What about the second one, top right? No? What's wrong with it? Yep. Or -1. Either of those is bad. Anything that's outside of our probability possibilities. Bottom left? Was a yes? Bottom right? No? Was it the sum on that one again? 1.04, a little too big. Okay. Questions determining if you do or do not have a probability distribution table. Very quick. Okay, so last couple things we're going to do are going to be on your paper now. If we have one of these, a discrete random variable, and we have our probability distribution, we can, from that table, find a mean, a variance, and a standard deviation. So these are going to be, again, on your formula sheet, as everything usually is. The mean, if you'll notice, looks kind of similar to what we were doing before with tables a couple chapters ago. The mean formula tells us take each of the probabilities, multiply it by each x value that they are the probabilities of, and then add those all up. So we're just multiplying two columns together and then adding them up. Very quick and easy. The variance and standard deviation kind of start to look like what we were doing before with variance and standard deviation, where we take our mean, we have to find that first, take each value, each x value minus our mean, we square it, that's the sum of squares that we ultimately find, but first we multiply by the probability to include that. And then once you have variance, we're going to take the square root of the variance again to get the standard deviation. And you can see we're using those population variables again for this, okay? All right, so on your paper, first one we're going to do is calculate the mean of a probability distribution. And I'll write the formula at the top here so you can have everything on one page. So we ultimately need to do this. And that's the formula for our mean symbol, okay? So let's fill in our table. X's are 1 through 5. Easy enough. 1, 2, 3, 4, 5. And I don't know why I have an extra row, but I do, maybe for the sum at the bottom. Okay. Probabilities, fill those in. 0.16, 0.22, 0.28, 0.20, 0.14. Okay. And then take each x and multiply it by its respective probability. So 1 times 0.16, 0.16. 2 times 0.22, 0.44. 3 times 0.28, I'll check myself on that one, 0.84. 4 times 0.2, 0.8. And 5 times 0.14, 0.7. And then we're just going to add all those guys up. And I get 2.94, and that is my answer. That's all you have to do for the mean. Okay, so you really might not even need those first two columns. If you're given to in a table, you can just kind of create a third row if you want to. Multiply the top row by the bottom row, then add up whatever you get in that bottom row. Questions finding the mean of a probability distribution table. Okay, so then the last thing we need to do is find a variance and standard deviation, and we're going to use the information that we had at the top. So what did I just say that mean was? 2.94. Okay, so we already got that guy. All right, let's fill in a couple things. So I've got my x's, I have my probabilities, 0.20 and 0.14. And then it says at the bottom, sum of the probabilities equals 1. So that's always something that we can kind of check as we're going to make sure we don't go too far without having a mistake in our work. Okay. All right, so then we're going to take each of our x's and subtract the mean. So that's the 1, 2, 3, 4, 5. 1 minus 2.94, negative 1.94. 2 minus 2.94, negative 0.94. 3 minus 2.94 is 0.06. And then I'll get 1.06, and then I will get 2.06. The next column just says x minus the mean squared. So that's the previous column squared, which is what we used before to find variance and standard deviation, the sum of the squares. All right, so 1.94 squared, I don't even in my calculator type those negatives in because it's not going to be negative anyway. 3.7636. 0.94 squared, 0.8836. 0.06 squared, 0.0036. 1.06, 1.1236, and 2.06. 4.2436. Okay, so I found my deviation. Found my deviation squared. And now we're going to take the deviation squared and multiply it by our probability. Okay, so 3.7636 times 0.16. 0.602176. I'm just going to give it all the decimal places. 0.8836 times 0.22. 0.194392. 0.28 times 0.0036. 0.001008. 0.2 times 1.1236. 0.22472. And 0.14 times 4.2436. 0.594104. And then we just add all of those up. Of course, like when you're doing Math Excel or test or whatever, you could always just stick with our round to 3 decimal places, so these don't get super messy. Sum at the bottom, 1.6164. 1.6164. Assuming I put all that in my calculator correctly. So you can label that. That is your variance, which is that lower k sigma squared. Okay. So then if we want to take it one step further and get the standard deviation's quick. It's just always the square root of our variance. 6.4. I get 1.271 is my standard deviation. Okay. And that's everything you need for 4.1 except for, we're going to do a couple problems tomorrow with expected value. It'll be a fun activity, I promise. And that'll finish up 4.1 for us tomorrow. 3.4 Math Excel is due tonight if you have not finished it. 4.1 Math Excel is going to be due on Sunday night. So tonight and Sunday night are your next 2 deadlines. All right. I'll do cell phone lotto, and then I'm guessing they're going to dismiss you pretty soon here. It said the senior photo was going to be at 8:30.